Hi, I'm Kim from Nesby, and in this video, we'll be talking about the fructose model, which is part of Lesson 3 of the Roads from Earth to Venus companion course. The objectives of this model are to help students understand how plants make fructose, which is just a type of sugar, using water, carbon dioxide, and energy from the sun. This is a micro model, meaning that it is modeling something that is way too small for us to see with our eyes, so we use a model to help us understand it. Another objective of this is to demonstrate one important process, which is photosynthesis, that moves carbon around in the carbon cycle. If you haven't seen the video about the carbon cycle game, you might want to check that out. Just to take a moment to talk about models, according to the Next Generation Science Standards, modeling is the practice of using or creating representations of things that are too large, too small, or too complex for us to understand just by observing them directly. A diagram, game, prototype, or even an equation can be used to model a situation to help us understand it better. In this case, we're using a diagram along with a model to build it with bingo chips to help model this process that is too small for us to see with our eyes. There is an online version of this available, which I'll show you in a bit, but we do recommend building the physical model if at all possible. Before you start the fructose model with students, you will need to do some assembly. First, you will need to assemble 6 baggies, each with 2 red and 1 black bingo chip. And you will need to assemble 6 more baggies with 2 white and 1 red bingo chip. These represent water, in other words, H2O, and carbon dioxide, CO2. But which one is which? In order to figure this out, you have to think about what do the molecules have in common. H2O and CO2 have oxygen in common. So that means that the oxygen must be red. All right, well, which has 1 oxygen and which has 2? Well, H2O has 1 oxygen and CO2 has 2 oxygen. So we know these represent carbon dioxide. The carbon is the black one, and these represent water, where hydrogen is white. Once you have assembled 6 carbon dioxide and 6 water molecules per model, then you're ready to move on to the next step. You will also need to print 1 fructose model card per each student or per each group of students. So these are the materials that each student or each group of students will need: the 12 molecule baggies and 1 printed card. Once your students have all of the materials they need, it's time to build the molecule. So you will ask students to take a water and a carbon dioxide molecule, and this process in real life of making new bonds and breaking other bonds is activated by light. So it can help for you to turn a light on. They will break the bonds and then place the new atoms where they belong on the card. So we have a carbon, we have these oxygen, and we have some hydrogen. And then the light goes off. You'll ask students to repeat this process of breaking the old bonds and making the new bonds until they have filled their card, matching up the color of all of these different atoms to build their fructose. So as your students are building their fructose model, what they will find is they need all of the molecules that you gave them of water and carbon dioxide to fill the spots for carbon and hydrogen. However, they soon run out of spots to put these red oxygen molecules. They will have quite a few of those left over. What this is demonstrating for students in this model is how the process of photosynthesis takes in carbon and releases oxygen back to the atmosphere. So this demonstrates the extra oxygen molecules that go back into the air. If for some reason you are not able to build the physical model, there is an electronic version as well, and I will show you how to use that now. The most important thing you need to know is that this model is in a Google slide, and you will need to make a copy of this Google slide for each student or group, and they will need edit access. You will be given the file in view-only access, so you'll need to make a copy of it so that your students can change it. This is what the fructose model online file looks like. As I mentioned, it is a Google slide, and you could see here that there are water molecules and carbon dioxide molecules, and there are instructions over here about moving the molecules into this box and then right-clicking in order to break the bonds. Follow down the instructions about making new bonds, and this will look familiar because it is that fructose model from that physical sheet. This is not ideal to use this online version, but if it's all that you have access to, hopefully it will help your students understand the process of photosynthesis a little bit better. In the lesson plan for lesson 3, there are quite a few discussion questions and essential learning listed there. You can help students to make connections between the carbon cycle model, which is covered in a different video, and this fructose model, one being a macro scale model and one being a micro scale, but they are definitely connected. The lesson plan also includes extension activities such as reversing the photosynthesis reaction to a combustion reaction to help students understand how they are the same reaction proceeding in opposite directions. If you need more information and support, please visit our website, nesby.org. Don't forget that W. We hope you enjoy using this fructose model with your students.